All right, ladies and gentlemen, welcome back to 5 Minutes of Math. This is Mr. Lunsford, and I'm glad you joined me this evening. Tonight's homework is for the evening of May 7th, 2018, and we're looking at our SOL review. This is our SOL review part 9. Let's get started. All right, so our very first question, and again, I'm paraphrasing, using a triangle and a parallelogram with the following dimensions, and I'm about to show you the image. What is the best estimate for the area of Virginia? Now, this is the image that's given in the book, or it's a very close representation. You'll notice that there's a triangle over here on my right, whose base is 254 miles and the height is 246 miles. And on the left-hand side, there's a parallelogram, and the height for that parallelogram is 67 miles, and the base is 170 miles. So if we use those measurements, this becomes a composite shape question. So we have a parallelogram and a triangle. The strategy here, take the areas, add them up. So let's go on through it. We have here for our parallelogram, our base is 170, our height is 67. We don't actually need the height for volume because we're not actually doing any volume, so just ignore that one. It shouldn't be there. All right, and our units are miles. So our area is just base times height. So 170 times 67 gives us 11,390 miles squared. Now let's move on to the triangle. We have our area here equal to 0.5 or 1/2 times base times height, and our measurements here are 254, 246. Again, we're not doing volume, so we don't need a height, and our units are still miles. Let's see, we have our area equal to 0.5 times base times height, 0.5 times the quantity, 254 times 246, and 0.5 times 62,484, and our area is now equal to 31,242 miles squared. We're not done yet because now we have the two numbers that we need to add up. So we have our area for our parallelogram and our area for our triangle. If you add those two numbers, 11,390 plus 31,242, you get 42,632 miles squared. The answer is A. The answer is A. All right, moving on to the next one. How much water is needed to fill this pool? Basically, that's the question that's being asked right here. And we have a cylinder. There's a radius. There's a height. And we are looking to figure out what our radius is going to be and just identify the pieces that we'll need to solve this question. Let's see, our diameter is 20, and what that means is our radius is 10. Divide our diameter by 2, you end up with 10 as our radius, and of course our units are feet. For pi, I'm using 3.14, and our height here is 4. And this time, since we are doing volume, we do need the height. So our volume equals area of the base times height. Volume is pi times radius squared times height. Our volume is 3.14 times 10 squared times 4. 3.14 times 100 times 4. 314 times 4, and our volume, our final answer, is 1,256 feet cubed, and our answer is going to be H for that question. All right, moving on to the next one. A cylinder has a volume of 280 cubic units. If the radius of the cylinder is double, what is the new volume? Now, this is a relationship question, all right? So this question requires that you understand the formula that goes with the volume of a cylinder. So you might be thinking, Mr. Lunsford, do we need to just kind of guess until we get the numbers that add up and multiply into a volume of 280 cubic units? No, let me show you. Our volume formula for a cylinder, like we just said, is pi times radius squared times height. Now, if we start here, I'm going to just rearrange this thing. I'm going to take the parentheses down, and we have radius squared times height times pi. Same formula, just in a different order. Now, I'm going to replace r with 2r. And what I mean by doing that is I'm going to double whatever my radius is. So we have our volume equal to 2r squared times height times pi. Notice I still haven't put any other numbers in there besides 2. Now, let's break down 2r squared. If you see that arrow, This is how you break down 2r squared using the order of operations. 2r squared is the same as saying 2 times r times 2 times r. If we rearrange that, it becomes 2 times r times r. 2 times 2 is 4. R times r is just r squared. So when we simplify 2r squared, we end up with 4r squared. So our volume now is 4r squared times height times pi. And what that tells me is that the 4 is the only difference between what we see now and where we started. So my conclusion is, just looking at the fact that that 4 is the only change that we've made from the beginning to the end, if we double the radius, that means the volume should be 4 times larger than it was before. So using that relationship, 280 times 4 is 1120. The answer should be A, but can we prove it? Let's go ahead and prove it. Now I did some playing around, and I came up with some dimensions that would give us a cylinder with a volume of 280. So let's say the radius is 5. That number for height is 3.5669. If we put all that together into our formula for the volume of a cylinder, we end up with 280 feet cubed. All right. Now, the actual number is like 280.00165, but we're going to call that 280. Now, if I double the radius from 5 to 10, and that's the only change I make, I keep the height the same, then we end up with our volume being equal to 1,120 feet cubed. So it turns out that relationship really does work. The answer really is A. The answer is A. All right, going on to number 4. A desk drawer contains 4 blue pens, 9 red pens, and 7 black pens. If the owner of the desk selects 2 pens without replacement, what's the probability that she'll select 2 red pens? All right, this is a dependent probability question. And we always have to figure out, are we working with independent or dependent probability? This is a dependent style question. Why? Because we're taking one object out and we're not putting it back. That's what makes it dependent. So we have blue pens, 4 blue pens, 9 red pens, and 7 black pens. First thing we always do with probability is figure out how many total objects do we have. 4 plus 9 plus 7 is 20. Okay? So our first event, we have a probability of picking 9 red pens out of 20 total objects. Okay, so that's 9 out of 20 for event 1. And since we're not putting it back, event 2, assuming we pull a red pen, we now have 19 objects left in our pool of objects. And we only have 8 red pens left. So event 2 would be 8 out of 19. The second time she picks that red pen, she has an 8 out of 19 chance of pulling that red pen. The first time was 9 out of 20. The second time was 8 out of 19. So we multiply that together. We end up with 72 over 380. Now, if we have that, our next step, oh, and by the way, I showed you what the decimal equivalents are down here, but since this problem is using fractions, we'll stick to fractions. If we simplify 72 over 380, what we do is find a factor for both the top and the bottom so that we can divide the top and the bottom and come out with an equivalent fraction that's a little bit smaller and simpler to understand. So it turns out the biggest number we can divide into the top and bottom without having any decimal parts is 4. So 72 divided by 4 is 18. 380 divided by 4 is 95. This fraction becomes 18 over 95. The answer is J. The answer is J. Moving on to our last part. What will the coordinates of the image be after point Q is rotated 90 degrees counterclockwise around the origin? So remember, counterclockwise is this direction. Okay, it's moving in the opposite direction of a typical analog clock. And there is Q. It's 3, negative 5. And again, I'm showing you the counterclockwise motion and clockwise motion. We're moving counterclockwise. So 90 degrees, see that red line? It's pointing to the origin. So that's our center of rotation. We're going to rotate 90 degrees counterclockwise. And that's what that point looks like if we do that. So we've rotated this point. Here's our new point down here in green. And that new coordinate is closest to being 5, negative 3. And that's actually what it is. So that's Q prime, our new position. 5, negative 3. So the answer here is B. The answer is B. And that's it. Y'all take care, and remember, math is not just about numbers. It's all about the relationships that surround us every day. Have a good one.